Good morning, we are young beginners. We are going to discuss the design review using HoloLens. Let me firstly give you an introduction on the BIM. BIM is the process of generating and managing building data during its design, construction, and during the building or access lifecycle. Typically, the process uses three-dimensional building modeling software to increase the productivity of the consultants and contractors during the whole access lifecycle. The process produces the BIM database, which encompasses the BIM geometry, spatial relationships, and geographic information. It's a new way of working using the new technology to facilitate project management and better construction process control. It's time for me to make a comparison between the VR and AR to better illustrate the differences. VR is a computer simulated environment which allows for the users to interact in a virtual world. The presentation of a VR image has no relationship with the reality, since the users can navigate freely around the visualized 3D virtual world. VR technology surely encourages the users to comprehensively understand the complexity of the simulated environment. It's also noted that the level of realism of the simulated environment is a major factor that determines whether the users have a practical experience in the simulated environment. AR would give an environment a personal computer interface that would consistently coordinate into the reality, which would help to facilitate the collaboration between the users in the most natural way. This means the presentation of the AR image is based on the reality, which contributes to the major difference compared with the VR.
Then I'll give a brief introduction of some common 3D visualization methods and the device we are focusing on. The first one I'm going to talk about is the CAPE system as shown in the diagram. It's known as an immersive virtual environment. And the second one we are going to introduce is the HTC Vive, which has the most distinctive features of lighthouses. The lighthouse first flashes a IR LED pulse, then wraps a room with vertical and horizontal lasers as shown in the right picture. The IR sensors receive the lasers and time difference between IR pulse and lasers web is calculated to know the position and orientation of trapped objects. The final device, which is also the device our group chooses, is the microscope HoloLens. It is the first commercially available AR HMD and contains features like high-resolution display, gesture interface, gaze and voice recognition control, etc. And the reason why we are choosing HoloLens over other devices is that unlike the very immersive VR, AR only superimposes images on surrounding real-life environments. And we think that it can achieve a more accurate and dynamic interaction to real life. Also, it has the highest mobility as it is based on the actual environments. It doesn't need to create a whole new virtual world and can suit the needs of the very dynamic construction environment and sites.
The first trial of HoloLens is at CIC BIM space. This is the procedure of trying the HoloLens. It is very important to connect the HoloLens to display monitor so that others can know what you are seeing. After picking the decided project file, pick Launch, a virtual BIM model will appear in the view setting. The BIM model of CIC MIC Display Center was used in the trial. After finding out the virtual model in the view setting, the user came close to the model and directed it to adjust its size. The user clicks Navigate and Street View buttons. After that, the user was placed inside the model and walked through the interior of the building model under the backdrop of the existing setting. There are some faults by the user after the trial. HoloLens is not suitable for providing an immersive experience of walking through the model. The backdrop obstructs the user from viewing the interior of the BIM model. There are also other potential difficulties when using HoloLens in construction industry, such as taking a long time for the BIM model with the large file size to be uploaded onto the Trimble portal. HoloLens should be connected to Wi-Fi and monitor for others to see, and HoloLens is very expensive. The second trial is to investigate the feasibility of design review using HoloLens. BIM model of a 3-meter brick wall with 2 windows was created and opened in HoloLens. Suppose an existing wall is going to be replaced by the brick wall. The designer would like to foresee the effects after construction. User then move the brick wall in front of the existing wall and adjust its size. The user would like to create the effect of the brick wall is superimposed onto the existing wall. The user tries to align the brick wall and anchor it onto the existing wall. However, the align function of the HoloLens doesn't bring about the effect. After that, she tries to stimulate the effect by enlarging the wall and fitting it onto the existing wall. It also missed the purpose of design review, though it may lack precision. After all, the designer can still get a rough idea of the visual effects of the changed design. While for better accuracy, user may leverage simultaneous localization and mapping technology embedded in HoloLens. With more softwares such as Unity and Visual Studio, design review of design options can be made possible.
Now I'll talk about some benefits of AR system for different stakeholders. For the building professions, the measurement of physical elements can be done easier and more accurately with AR. Also, design changes and error detection can be more convenient and accurate as shown in the diagram from the left. From the research by multiple scholars, including our lecturer, Dr. Xiu, it states that AR has significant advantage in reviewing visual elements like color and texture. And most respondents think that the experience of AR system is innovative and creative. For the workers in site, they don't need to rely on drawings anymore, and they can identify any installation errors quickly and accurately, as well as more confirm with any installation paths, positions, and directions. And however, some limitations are still found with AR. Firstly, the AR system requires 3D modeling in the first place, but not all projects in Hong Kong adopt BIM. But the most fundamental reason should be that AR may not be accepted by the industry. The construction industry itself is very innovation resisting. It takes years for the development of BIM in Hong Kong, and still, not all projects in Hong Kong nowadays use BIM. Not to speak of other innovation like AR.
Some suggestions are made to further facilitate the use of AR and BIM applications in Hong Kong construction projects. Firstly, the high initial cost for the innovative technology into construction should be addressed. HKCIC and the government have actively promoted the use of BIM in recent years. To encourage the use of combination of the AR and BIM into the construction projects, it's important that the government should provide sufficient support for the potential users, especially for those with limited resources and budgets, such that they can be more persuaded in utilizing these new technologies without great concerns in the course. Secondly, the clear guidelines and standards on the use of BIM and AR technologies in the construction projects should be established by the government. Setting up a clear BIM standard is essential in fostering the collaborations between the different concerned parties in utilizing these technologies. Lastly, more training should be provided to the concerned parties to enhance their understanding in BIM. That's the end of our presentation. It is expected that the combination of AR and BIM technologies will be more and more compatible for concerned projects in Hong Kong. Thank you.